Okay, in this problem we're going to talk about how to collect like terms, and we get to tone it down a little bit. From every example from here on out, this is example 6 through the rest of the videos, we get to solve in an interval, which is pretty nice. That means none of the in-pi business at the end of the equation. We're just going to cut it off with the first couple of solutions. So, if we're answering between 0 and 2 pi, then we do know that our answer is in radians. Let's go. First thing that I want to do in this problem is I want to get all the signs together. So I'm going to add sine of x to both sides. That tells me that 2 sines of x plus the square root of 2 is equal to 0, right? I added sine of x over. Now if that's the case, now I can get sine of x by itself by saying that 2 sine of x is equal to negative square root of 2 by subtracting the square root of 2 over. And then I'm going to divide by this 2 over here. That means that the 1 sine of x is going to be negative square root of 2 over 2. So I know that I'm going to draw now two triangles. They're going to be where the sine is negative. And sine is negative in the bottom two quadrants. I know that the opposite is going to be negative square root of 2. And I know the hypotenuse, because it's sine, is going to be 2. Right? That's what I get from this. Now, if you're not really sure how to get the angle in between, I know this is a 45-degree angle because I've done these long enough. But if you're not for sure, there's two ways to go from this point to find out what that angle is. The first thing I do is this. If sine of x is negative square root of 2 over 2, then x is the arc sine of negative square root of 2 over 2. And this is going to tell me my reference angle. So I can type this in on my calculator. I can say, and notice I am in degrees mode, but I can say the arc sine of negative square root of 2 divided by 2. Notice I ended the parentheses for the square root, and that tells me it's 45. Ignore the negative. What that does is that tells me that it's this one right here. The value inside the triangle is 45 degrees. And then you just have to make adjustments for the quadrants. So, if I want to talk about what these two angles actually are, then I need to go and I need to say, well, that's 180 plus 45. So one of my angles is 225 in degrees. The other angle is going to be 315 degrees. Now my last portion of the problem is to convert these to radians. And it turns out that this is 5 pi over 4, and this is 7 pi over 4. And I'm done. Pretty nice, right? By the way, the other way to solve this problem is to understand that the square root of 2 over 2 is the same thing as negative 1 over the square root of 2. So then, if you look at it this way, you look at it 1 square root of 2, you see 1 square root of 2, and maybe that's a little bit easier to visualize, right? That's the other way to get 45 degrees if you don't want to do arc sine. So we're done with this. No in-pi business at the end. Let's go through and let's do the same thing here. The only difference between these two problems, it looks like, is the fact that this square root has been turned negative, right? So I would go through the exact same steps, except in the end, I would get the opposite sign. On this problem, I would have gotten sine of x is equal to positive square root of 2 over 2. And so the only difference here where I was attacking this problem is when I drew my triangles, I would draw them in the quadrants where sine was positive. That's 1 and 2 instead of 3 and 4. Okay? Now, if we look at it like this, 1 over the square root of 2, this time we see that we have an opposite of 1 hypotenuse to square root of 2, right? And we can tell that this is going to be 45 degrees. So instead of answers of 225 and 315, I get the angles up here of 45 degrees, and this one turns out to be 135 degrees, which I state as, in radians, x is equal to pi over 4 and 3 pi over 4. And I'm done with this problem.